All right, guys, this is the video for section 10.3, and in 10.3 we're going to be talking a lot about chords of circles. Okay, now if you remember a chord, so if we have a circle, a chord is basically a segment that starts at one point on the circle and ends on the other. Okay, it doesn't have to be a diameter, but it does need to go through the circle. All right, so let's do a few warm-up problems. There's 3 here. And notice that in each of these, the diameter is 12. So if the diameter is 12, that means the radius has to be half that, which is 6. Okay, so I'm going to do number 1. So if the radius is 6, that means this is 6, and that means this is 6. Okay, and if this is a 90-degree angle, that means this has to be a 45, 45, 90, because if they have 2 congruent sides, they're going to have 2 congruent angles. And therefore, a 45, 45, 90 triangle, x, x, and then x square root of 2. So the hypotenuse is just 6 square root of 2. Okay, I want you to go ahead and try to figure out 2 and 3 on your own, and then we'll go over it. All right, guys, on number 2, we know that this piece is a radius and this piece is a radius, so both of them are 6. Now, this entire piece right here is also a radius, so it would be 6, but if you notice on these 2 hash marks, it cuts it into 2 congruent parts, so this here is 3. Okay, so I set up, we have a right triangle, 3 squared plus x squared equals 6 squared, x equals 3 square root of 3. Okay, now on number 3, you can determine that these triangles are congruent by the side angle side theorem, and if they're congruent, this and this are corresponding sides, so you would set them equal, and you'd get x equals 11. All right, guys, so there's 3 main theorems in this chapter, and this is the first of them. It's the congruent corresponding chords theorem. It basically said that in the circle or of congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So in other words, this arc here and this arc here are congruent if and only if this chord and this chord are congruent. Okay, or you could flip that around to where if you know the arcs are congruent, then the chords are going to be congruent. If the chords are going to be congruent, then the arcs are congruent. All right, so the next theorem, so theorem 2 of number 3, is the perpendicular chord bisector theorem. So it says if the diameter of a circle is perpendicular to a chord, okay, so here's a diameter, here's a chord, and we know that they're perpendicular, meaning it crosses at a 90-degree angle. What that means is that this arc and this arc are congruent, and also this part of the chord and this part of the chord are also congruent. All right, so this is the third of the 3 theorems. It's the perpendicular chord bisector converse. So it says if one chord of a circle is a perpendicular bisector, so here we know it's perpendicular and it bisects it, then we know that this here has to be a diameter of the circle, so it has to cross through the center of the circle. All right, let's look at example 1. Okay, now it says in the diagram, circle P is congruent to circle Q. So these 2 circles are congruent. Okay, and then it also gives us FG is congruent to JK. So we want to find the measure of angle FG, so we want to find this, knowing that JK is 80. Okay, so we're going to go back to this first theorem right here that says if the chords are congruent, then the arcs have to also be congruent. So that would mean this has to be 80 degrees as well. All right, let's look at example 2 now. Example 2, we're going to use the second theorem here, which tells us if a diameter is perpendicular to a chord, then it both bisects the chord and it cuts the arc into 2 congruent pieces. Okay, so we're going to use that here. So here we have a diameter that's perpendicular, which tells us it bisects this. So if this is 7, this has to be 7. And it also makes it to where this piece is congruent to this piece. All right, so part A asks us to find HK. Well, HK is this chord right here. Okay, and if both of these parts are 7, then this chord has to be 14. Okay, now the next one is to find HK. Okay, well, in order to do that, I have to find each one of these. Now remember, this diameter cuts these two arcs into two congruent pieces. And because they're congruent, that means that 11x has to equal 70 plus x. Okay, now it's just algebra, so let's subtract x from both sides. Oops, 10x equals 70. Divide both sides by 10. I get x equals 7. Okay, now if x equals 7, when I plug it in, 11 times 7 is 77, and then 70 plus 7 is 77. So the entire arc would be 77 plus 77, which would be 154 degrees. All right, I want you to use what we've learned to go ahead and do A and B on your own. Okay, you're going to use this theorem right here, the congruent corresponding chords theorem, for both of them. All right, so we know that because these chords are the same length, that arc AB and arc BC are also going to be congruent. So if on A, if the measure of AB is 110, the measure of BC has to be 110 as well. All right, now on part B, it says that the measure of AC is 150. All right, so if AC is 150 and all the way is round is 360, that means from here to here has to be the remainder 210 degrees. Okay? Then once again, we know that this arc and this arc are congruent, so if we divide this 110 by 2, we'd get that each of the two arcs are 105 degrees. All right, I want you to go ahead and do example 4 on your own, and now you're going to use the perpendicular chord bisector theorem. All right, guys, so what we have is because a diameter is perpendicular to a chord, that means it bisects the chord, so CF is 5, and that also means FE is 5, so the whole thing then has to be 10. And it also bisects this arc here, so that DE, or CD, sorry, is congruent to DE. So what I would do is I'd set 9x equals to 80 minus x, solve it, and you get x equals 8. Guys, that is not the right answer. So when x equals 8, that means 9 times 8 is 72, 80 minus 8 is 72, and so the measure of CE then would be 144 degrees. All right, so we have one more theorem in this section. It is the equidistant chords theorem. And this tells us that in the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so in other words, if CD and AB are congruent, then this small piece from the center of the circle to the chord, and remember, we're talking about the perpendicular distance, is going to be equal to this here. All right, so let's look at this. All right, so it says QR equals ST. So just this right here tells us that CU has to be congruent to CV. So this part here tells us that CU is congruent to CV. Okay, well now CU is 2x and CV is 5x minus 9. And if those two parts are congruent, I can set them equal to solve for x. So do a little algebra. Negative 3x equals negative 9. Divide both sides by negative 3 and I get x equals 3. Now if I plug it in, 2 times 3 is 6. And 5 times 3 is 15 minus 9. So this is also 6. Okay? So CU and CV are both equal to 6. All right, then if we go on, it says that QR and ST is 16. Well, now if you notice, this diameter cuts it perpendicularly, which tells me that it bisects this chord. So if it's 16, that means this is 8 and this is 8. All right, now we want to find the radius. So I'm just going to draw in this radius right here. Okay, now I know this is super messy, so I'm going to take out this triangle right here, and I'm going to redraw this out here. Okay, so we have a Q, a U, and a C, and this is my radius. Okay, and I said my CU was 6. It's given that this here is a right angle, and my QU has to be 8. Okay, so now I have a right triangle. I know 2 sides. I can find the third by doing the Pythagorean theorem. So 6 squared plus 8 squared equals r squared. So 36 plus 64 is r squared. 100 equals r squared. Undo a square, you take the square root. So my radius is 10, and that is how you would do this problem. All right, I want you to try to do example 6 on your own. It's pretty much identical to example 5. It's the same process. And I do want you to make note on your notes that there will be a question like this on the test, so make sure you know and understand how to do this. All right, let's look at this. All right, so you have JK and LM are both 24. So that means JP is half that, which is 12, and PK is half that, which is also 12. And then you have that NP is 3x and NQ is 7x minus 12. And these have to be the same length since these chords are the same. So if you set them equal, solve for x, you get x equals 3. And then when you plug 3 into 3x and 3 into 7x minus 12, you get that each of them are 9. Okay? Now, I drew this radius right here, and I pulled it out. So it formed this triangle right here. So 9 squared plus 12 squared equals the radius squared. You do a little math, and you get, or you should have gotten, the radius is 15.